Hi, I'm Nikki. Welcome to my channel about game development. This is a video in a series dedicated to learning Unity's animation system. In the previous video, we learned to give players control over character animations using two-dimensional blend trees. Today, we're going to learn how we can retarget animations from one character to another. Alright, let's get going. At the start of the series, we learned to download free characters and animations from a free Adobe platform called Mixamo. We proceeded by learning to import, set up, and control them in Unity. Let's rewind back to our starting point. We'll start by downloading a single jumping animation from Mixamo with the usual settings, except this time we'll add the skin and export a different character than the one that we initially downloaded. If you're new to the series, any character will do, and feel free to use the settings on screen. Opening Unity, we'll import this new character and animation. Next, we'll open up the asset store and download and import two free additional characters, Jammo, which is the free mascot character of the YouTube channel MixAndJam, and Space Robot Kyle, which is a classic free character provided by Unity for download. In newer versions of Unity, we can download and import these characters from the package manager. When importing Jammo, we'll need to be sure to deselect unnecessary folders. We really only need the materials, models, and textures. Now to get everyone starting from the same place, let's start by adding Jammo, Space Robot Kyle, and our new Mixamo character to the project hierarchy. If our projects are URP or HDRP, we will need to upgrade the materials of our characters by pressing Edit, Render Pipeline, Universal Render Pipeline, upgrade project materials to Universal RP materials. Additionally, our Mixamo character may have textures packed into the FBX file. To extract these materials, simply select the character from the Project tab, press Materials in the inspector, and click Extract Textures. Great! Next, we're going to add Animator components to each character. Create a new Animator controller, titled Retarget Controller, and select this controller using the circle selector. If you're starting from previous videos in the series, you may have the original Mixamo character from previous tutorials. For this character, we can remove the old animation controller, disable any scripts, and reuse the Retarget controller. Great! Now let's begin by demonstrating how the jump animation we just downloaded is not currently compatible with any of our characters outside of the original character that it's attached to. Duplicating the animation, we'll rename the copy to Test Jump. Next, we'll add the animation to our Retarget controller as a new animation state, and set Test Jump as the default animation state. Entering play mode, we'll see that our new Mixamo character performs the jump, but the others don't. But why? To get a better understanding, we can take a look at the animation itself. If we open up the animation tab, we'll be presented with nothing. This is because we need to select either the animation from our project tab, or we can just select the characters in the hierarchy. Let's select the working Mixamo character, and we'll immediately see the animation tab be populated with new data. In the left panel, we'll see all of the bones that are modified in the animation, and in the right panel, we'll see the keyframes. Each key stores the changed parameter values per bone for every frame. If we press on the preview button and press play, we'll see that the Mixamo character performs the animation. Everything works as expected. Now let's select any of the other characters. We'll find that this animation currently is incompatible with any other character. When looking at the bones in the animation, Unity will tell us that each bone is missing. And if we want to be a little more specific, we'll notice that the difference in this particular example is that the bones in the new animation all have different names. So can we simply rename all the bones in our selected character's rig in order to use the animation? Well, this might work if the bone positions are fairly similar between the characters, but if the character models have different proportions, we'll end up with an unusable result like this. So what can we do to fix this? How can we share animations between models that are seemingly very different? The answer is Unity's avatar system and Humanoid Rigs. We'll start by selecting our imported character in the Project tab. In the Inspector window, we'll see 4 tabs: Model, Rig, Animation, and Materials. For today, we'll just be using the Rig tab. By selecting Rig, we'll be presented with new settings: Animation type, Avatar definition, and skin weights. Let's start from the top. We'll notice when selecting the animation type dropdown, we have 4 options: None, Legacy, Generic, and Humanoid. Selecting None will actually disable the character's rig, so it won't animate at all. Legacy is Unity's original animation system from years ago, prior to their purchase of Mixamo, which is the backbone of Unity's current animation system. Unity's documentation states not to use Legacy, and that it's simply there to support old projects that were already using the Legacy animation system. Generic is what we've been using in this series up to this point. It's the default animation type when importing character FBX files from Mixamo and Blender that include character rigs. And finally, we have Humanoids, which is Mixamo's solution for retargeting animations between humanoid characters. Typically, we might think of humanoids as bipedal characters, like humans, orcs, elves, robots, and aliens. Let's select Humanoid. We'll notice that the avatar definition setting is now set to create from this model, and a new configure button is grayed out. This is one of the 2 selectable options, the other being copy from avatar. With these being the only 2 options, we now understand that avatars are required for humanoid rigs. Pressing apply, we'll see configure is now selectable. This will take us to a completely new menu within Unity, so before we press it, let's cover the remaining settings. Skin weights are used to modify the vertices of a mesh on a per bone basis. In a 3D modeling software like Blender, we are able to perform a process called weight painting, where we designate which bones will adjust specific vertices when the bone moves. When weight painting, we can have multiple bones impact a single vertice. For example, if we really wanted to, we could have the toe bones control the head of our character. So taking this back to Unity, skin weights has a default value of 4 bones, which can control the vertices of the character mesh. But this setting can also be set to a custom amount if our model has vertices that are impacted by more or less than 4 bones. Additionally, when custom is selected, we can give it a minimum accepted influence amount, so that bones that have less than a certain percentage of control over the vertices won't be included. Unity's default value of 4 bones is to enhance performance, so it is totally possible that if certain bones are neglected, a model may deform in unexpected ways. Here are a couple examples from Unity's forums, where developers' meshes were deforming differently than they did in the modeling software. Today, we're going to stick with the default value of 4. And the last setting in this window is the Optimize Game Object Toggle, which is another setting that appeared when switching to Humanoid. This will remove the transform hierarchy from the imported model, and essentially bake it into the avatar and animator component. It's recommended in the docs to apply this setting before shipping the final product. I did notice that if we have an animator component already attached to our character in the scene hierarchy, our character will disappear. Be sure to apply the setting without an animator attached, or you will need to remove the character and add the prefab back to the scene. For now, we'll leave the optimization unchecked. We now have a solid understanding of all the rig settings. Pressing configure, we'll see a completely new menu in the inspector, and our scene view transforms into an isolated view of our character. In the inspector, we'll be presented with an outline of humanoid character with small circles at designated parts of the body, and below, we'll see a list of body parts associated with each circle. The dotted circles are considered optional. When first configured, Unity will attempt to auto-map each bone from the character rig to its corresponding bone in the list by searching for specific names and abbreviations that match. When using characters from Mixamo or one of the many humanoid characters downloadable from the Unity Asset Store, it's more than likely that the auto-population will have each matching bone properly sorted when first entering the screen. This is why the list is already filled out. However, if we make our own characters in a 3D modeling software such as Blender and have different names for our bones than what Unity is expecting, we'll instead be presented with a red character outline, and the list will have empty selectors that we'll have to go through and map ourselves. And for more complex characters and animations, we also have the options to map bones associated with the head and both left and right hands, all of which are optional. At the bottom of the list, we'll see 2 drop-down menus titled Mapping and Pose. Mapping has 4 options: Clear, Automap, Load, and Save. Clear will remove all paired bones. An automap will search through the list and paired associated bones found in the character rig, the same function that is performed when we first configure the humanoid avatar. Again, this only works if Unity can find the bones by name. Load and Save allow us to save and reuse our list of mapped bones. This would be useful for situations where the automap failed, and after we finish manually mapping the bones on one character, we could save and then load that mapping for other characters with the same bone names. The Pose dropdown just has 3 options: Reset, Sample Bind Pose, and Enforce T-Pose. When the humanoid is first configured, if the auto-mapping of the bones works as intended, Unity will automatically apply Enforce T-Pose, which is what we see here. If we press reset, the character will shift its bone transformations back to the starting frame of the animation attached to the character, or the rest pose if the character doesn't include any animations. And lastly, sample bind pose will reset the character's bone positions back to the character's bind position. The bind position is the position that the character mesh was in when initially binding or connecting the bones to the mesh. The binding process is done inside of a 3D modeling software, and the bind pose is hidden and stored inside the FBX file. Any changes we make in this menu will need to be applied before pressing Done to exit out of the avatar configuration process. Before we move on, we have a second tab titled Muscle and Settings. This menu is for modifying the muscle constraints our character currently has. We can preview these constraints and how they impact the possible range of motions for our character by moving the sliders around in each column and row. If we want to adjust the constraints, we would do so in the per muscle settings and the additional settings and press Apply. The muscle settings are typically used when converting models from generic to humanoid that have exaggerated character meshes. For example, a character with massive arms might experience clipping where a smaller character would not. So we can adjust the constraints of the muscles to limit the bend in the arms and reduce any visual issues. Okay, we've now completed a breakdown of Unity's Humanoid Rigs setup. How does this help us? The answer is quite simple. When we convert the character to humanoid, this process generates a humanoid avatar, storing the new bone hierarchy that is interchangeable with other humanoid avatars. It also converts any animations that are included in the character FBX file from generic to humanoid, meaning any humanoid character will be able to use these animations. Let's go ahead and create humanoid avatars for all of our newly downloaded characters. Once completed, we'll select each of the characters in the hierarchy, and using the circle selector in our Animator component, we'll match the newly created and corresponding avatar. Pressing play, we'll now see some possibly unexpected results. Now none of our characters are jumping. This is because we duplicated the animation before we switched to the humanoid rigs, so that animation is still tied to the old bone hierarchy. So the last change we'll need to make is to duplicate the animation one more time from the now humanoid version of our Mixamo character. This time, we'll call it Retarget Jump. We'll delete the test jump and set Retarget Jump as the default animation state. Pressing play, and voila! We have successfully retargeted our jump animations from one character to another. Amazing job! With what we just learned, a slight modification of the scene, and a brand new animation, we can get an awesome result like this. Now before we end today, there are a couple of important notes. To start, if we downloaded animations from Mixamo without the skin, we still can and need to switch the rig type to humanoid. We also need to select copy from avatar and select our downloaded Mixamo character's avatar. And when downloading these animations on Mixamo, be sure to have the same character selected as the one you use for this tutorial. This way, the animation FBX will have the same bone names. This will allow it to be used by humanoid rigs. Next, if you've been following along through the series from the very beginning, you will need to switch the rig type on all of the animations in your animation states to humanoid if you want them to work with humanoid characters. I recommend renaming the new humanoid copies of the animations to avoid confusion. And when selecting the duplicate animations, we also want to change the root transform rotation setting from body orientation to original, and check bake into pose, for our animations to look as expected. And last but not least, if you are completely new to the series, in previous videos we learned to control animations through player input. With the knowledge that we attained today about humanoid characters, we can combine that with the teachings of previous videos, and actually give players control over any of our humanoid characters and animations. It's rad! Awesome work today. If you liked what you learned, please consider pressing the like button and subscribing to the channel. It really helps the channel grow and tells me that we're covering content that you care about. In the next video, we'll take a look at animation state layers, and not long after, we'll take a look at animation-based events. If you'd like to join a growing community, I'd love to have you as a member of the channel Discord. The link is in the description. But that's all for today. Thank you so much for watching, and we'll see you in the next video.